Hello everyone, very good afternoon one and all. So welcome to day 4 afternoon session in IoT STTP program organized by Department of ECE, Narasaraopeta Engineering College. So we warmly welcome you all to the afternoon session and the 1 week national level online STTP on IoT with smart cities. So in the morning part, we have discussed about how to upload the sensory data onto the IoT cloud, and also we understood how to create an IoT scenario for smart parking. So in this part I would like to give you a brief on IoT ThinkSpeak again, because we have left part with the Matlab analysis and all, right. So we'll complete the Matlab analysis part in the IoT ThinkSpeak cloud, and then slowly we'll jump into AWS IoT Core. So on the day 1, if you see, I have introduced what is AWS IoT Core and what kind of use cases can be developed in AWS IoT Core. I'll share all the presentations for your quick overview sometime today in the drive. So I'll put all the presentations in the Google Drive. I'll share that link in the WhatsApp group. So sometime today, so that you can also have a quick outline on the AWS IoT Core. So this is given on day 1. So we'll be using this AWS IoT Core. We'll see what kind of services are there, how to upload the data to IoT Core. And so in the morning part we have discussed about how to upload a sensory data into the IoT ThinkSpeak cloud, isn't it? So now in the afternoon session, so after talking about ThinkSpeak analysis, so I'll be talking about how to upload data onto IoT Core. So that will be my brief agenda of today's session in the afternoon. So let me jump into that. So morning, if you look at, so I have connected my Raspberry Pi, and also we have created some scripts on Google Colab, isn't it? So morning I have shown you the outputs of IoT, the sensory data uploading and also sensory data downloading through API request, isn't it? So let me open that. So we have a channel here which is IoT NEC STTP Smart City. So in the morning we have uploaded some sensory data, the ultrasonic sensory data. So let us understand how to integrate Matlab scripts with IoT ThinkSpeak data. So that is the part which is left out in the IoT ThinkSpeak part. So let me use magnifier also. Let me open magnifier. So if you missed the morning class, you can go through the video which is there in our YouTube channel with a topic called smart parking. So you can go through that video. If you go through that video, then only you can understand this video, okay? So because they are interconnected. So all the sessions are there recorded in our YouTube channel, so you can play so whenever it is needed. So morning we have uploaded the sensory data into the field 1 chart from Raspberry Pi onto ThinkSpeak IoT Cloud. So here I would like to show you how to integrate your Matlab scripts. So if you have any Matlab script on your desktop PC, so how to integrate that Matlab script with IoT data which is getting stored here. So that is what I would like to show here. So this is called line graph, right? So a line graph is plotted based on the values. If you move your mouse to the data point, you can able to see what is the data, what is the sensor name, and also the timestamp there, when was the data uploaded. So you can able to see those kind of details when you move your mouse to the data point there. So let me jump into Matlab analysis. So let me click on Matlab analysis here. So let me show you how to have your Matlab script running to the running on IoT ThinkSpeak data. So here you can able to see some templates which are like custom no starter code, get data from private channel or get data from public channel or get data from a web page, and also you'll be having some examples like sample code to analyze and transform data. So calculate and display average humidity, calculate wind chill and update channel. So remove outliers from wind speed data and all. You can able to have different types of sample codes here. Okay, so let me click on the simple script, something like get data from private channel, because our channel is private. So let me have that template. So let me click on create. So when you click on create, you can able to see some MATLAB code which is generated automatically. So this is called template, right? So templates are nothing but already there will be some predefined MATLAB scripts. So they will be showing the predefined MATLAB scripts here. So if not, you can also have something like in MATLAB analysis you can. So if you have your own code, then you can select custom. So no starter code. So then you'll get the empty the empty code. So you can have your MATLAB code here, and you can click on save and run. So when you click on save and run, so the MATLAB code will be executed here. So if you have your own code, something like MATLAB machine learning analysis, or MATLAB the data analysis or data visualizations, you can paste the code here and you can click on save and run, and you can click on save and run, then immediately you can able to see output here. Okay, so so in the demo part I would like to show you the template. Okay, so let me select some templates. So get data from private channel, whatever. So I have selected some template which is get data from private channel. As our channel is private, so I just wanted to read the data from the private channel from the MATLAB script. So there is a sample MATLAB script available here, and if you see the MATLAB script and Python script looks similar, right? So here also there is no need of intimating any data type. So we can have variables directly, we can have assignment directly. So you can able to see here. So percentile is nothing but comment, right? So we are aware of it. And read channel ID equal to square bracket. There is no read channel ID here. So we need to pass the read channel ID, and also we have to pass a read API key. So and also if you want to write the data into another channel, you can have write channel API key here, and also write channel ID, so that the data can be read and written into another channel. So here let me create one more channel, so that I wanted to write data. So here in this MATLAB script, if you see, so the data will be read from one channel, and they are writing the same data into another channel. Okay, let me create one more channel for this MATLAB script. So let me open it in a new tab. So let me take this channel average humidity, so which is already there, right? So let me clear the channel. So let me clear the channel. So when you clear the channel, all the data associated with this channel will be erased. Okay. So click OK. Now the channel is empty. So let me change the name. Let me put ultrasonic sensor. Okay, let me have something like ultrasonic sensor demo, whatever. So I wanted to read channel data from MATLAB, and I wanted to write the same data into this channel, say ultrasonic sensor. Okay, so let me click on save channel. So let me save this channel, which is ultrasonic sensor. Let me jump into the MATLAB analysis code. So let me reload this page. Okay. So on the right side, you can able to see the channel infos. So what is the weather monitoring? So here I can see the channel names, so which were there in my account, weather monitoring system, and also IoT STTP. So this was a channel which we have edited, which is ultrasonic sensor. We have channel ID and access is private, and you can able to see read API key and write API key. So morning we have created this channel IoT NEC STTP Smart City. So you can able to say it's read API key and also write API key here, isn't it? So let me see that. Okay, so let me add some details here. So read channel ID equal to, so let us have the read channel ID here. Let us have read channel ID. So what is the read channel ID? Read channel ID is nothing but, I wanted to read data from IoT NEC STTP Smart City channel. So let me copy this read channel API key into here, read channel ID, and let us have single quotation. Okay, so this is API key. So let us paste the API key here. Okay, so this is channel ID, so we have to pass an integer value. So the channel ID is here, so let me pass an integer value. Okay, write channel ID, so I wanted to write to this channel ID, just given here, and write channel API key, so we have to copy the write API key. Okay, so here so I have edited all the parameters here. So I have edited, I have passed the read channel ID, which is like the input channel here, which is NEC STTP Smart City channel. So I copied the data. So I wanted to copy the data from this channel and I wanted to paste it here in the ultrasonic sensor channel. Okay, so we have ThingSpeak read. So we have ThingSpeak read. So we are passing the read channel ID and also we are passing read key here. So when you pass read key and read channel ID, the data will be read, and that data I am storing it in analyzed data, and then analyzed data I am just passing it here in the ThingSpeak write. So let me click on save and run. So when you click on save and run, your Matlab script will be running and you can able to see some outputs here. So here as of now we are not printing any data, right? So let me open the channel which is the ultrasonic sensor. So let me reload the page of ultrasonic sensor. You can able to see the data there. So 175.34. You can able to see the data 175.34. So which is the distance getting called from this channel. And that data you can able to see it here. So here as of now when you run it for the first time, so you can able to see that data, right? So every time this MATLAB code has to be executed whenever the data is inserted. Okay, so whenever the data is inserted, so this MATLAB script has to be executed. So when you click on save and run, so your program will be executed. So whenever the program is executed, you can able to see the same data which is coming to here. So you can see two entries now. So I have executed the program 2 times. So what is the value there? 175.34 and also 175.34. So there are 2 entries here, which means that I have executed program 2 times. So what is happening in the program? If you look at the program, so it is reading the data from STTP Smart City channel. So the last data which is getting which is stored in this STTP Smart City channel is read by using this function, and the data is just passing into the new channel. So let me run it once again. So when I run it once again, so you can able to see 3 times. Okay, so the entries are 2 as of now. So let me reload the page. So when I reload the page, you can able to see 3 entries as 3, because 3 times I have executed the program. But when I execute 3 times, always your past data is same, right? Always your past data is same. So that is why you can able to see a single straight line here. You can able to see single straight line here, because all the data is same, because we are not uploading any raw data like. So that is why you are getting the same line on the ultrasonic sensor. Okay, so let us execute this program automatically. Let us understand. So here we have taken some sample template which is a MATLAB script, and this MATLAB script, what it is doing there, it is reading the data from one channel and copying the same data to another channel. Okay, so this is the main agent of this MATLAB script. So this MATLAB script is doing like it is copying the latest data and passing it to the ultrasonic sensor. So when you are running it manually, so manually it is collecting data. So manually it is collecting data and posting to another channel which is ultrasonic sensor. Okay. So now the target is like, you have to execute this program automatically, because always you cannot sit before system and always you cannot run this program, right? So we have to make some automatic executions based on the application context. Say if you want to analyze the data, so when you click on save and run, then the data will be analyzed, say. Then you cannot sit before the system and you cannot click on the save and run button always, right? So we have to create some the timer control, or we have to do some react mechanisms here. So we have to create some either time control. What is time control? So you can see here, schedule your saved code to run at a specified time. Say for example, when you click on time control, so they'll ask you to create a timer. They'll ask you to create a timer. They'll ask you to create a timer. And say if you take 2:59 p.m. then every day at 2:59 p.m. every day when you put recurring, so every day at 2:59 p.m. what will happen? This MATLAB analysis will be executed. What is selected here? So get data from private channel 6. So that is the MATLAB code, okay, so which is created in the previous step. So when you click on save time control, what will happen? Every day at 2:59 p.m. okay, plus or minus 0 minutes. So at 2:59 p.m. what will happen? This MATLAB program will be executed. So something like, whenever a time alarm. So whenever a time takes 2:59 p.m. so there is an action called. So what is the action here? MATLAB analysis. So in the MATLAB analysis, what kind of script it is running? It is running a script called get data from private channel 6. So then immediately when you click on save time control, so every day at 2:59 p.m. so your program will be executed, your script will be executed on IoT ThinkSpeak. So this kind of interface is there. This kind of the time control is available on IoT ThinkSpeak Cloud. Say morning, say every day morning at 6 o'clock you have to switch off your the college, say street lights. Say if there are street lights available in the college campus, if you want to switch off it automatically, then you can create an alarm here. Say 2:59 p.m. at 2:59 p.m. or at 6 o'clock a.m. you can you can create some actions here. Okay, immediately what will happen at 6 o'clock a.m. so your street lights will be off automatically. Okay, or when you are working on something like aqua ponds. So every day, every night at 2 o'clock, what people do is in aqua ponds, they used to switch on the aerator. So they generally what people do is they put some labor. So and labor will be going to the field and he will be switching off the aerators manually. So here instead of going it manually, you can switch off the aerators automatically when the timer is set here. So you can do any kind of action, not only MATLAB analysis, you can also communicate with devices and also you can do little analysis around it. So you can do any kind of action here. Instead of MATLAB analysis, you can also use Think HTTP, Think Pvt, Talkback. So all these actions are available here. Immediately you can push data to the devices and also devices can be accessed thereby from the ThinkSpeak IoT Cloud by using simple time control here. So you can have one time, and also you can have recurring here. Okay, so when you put recurring, so you have to select MATLAB analysis, then immediately you have to select the code. So as of now the code is get data from private channel 6. So when you click on save time control, so every day at 2:59 p.m. so the data from channel will be copied into another channel here. This is called time control. So instead of time control, there is one more application called React. There is one more application called React. So let us create a new React. So here condition type, you can keep it number, whatever, numeric. On data insertion, so condition type as of now it is floating point value, right? Numeric. On data insertion, or you can have a test frequency here, every 10 minutes, every 30 minutes, every 60 minutes. So I'll put on data insertion. If channel like ultrasonic, IoT, NEC, smart city. Okay. Field 1, if ultrasonic sensor is greater than, say if the slot is empty, so if the slot is empty you will get greater than say 50 centimeters. If the slot is empty, so you will get ultrasonic sensor distance greater than 50. If the vehicle is available, if the vehicle is parked at at the respective slot you will get a less distance. So say 50 or 100, whatever. So let's put 100 centimeters. So if the distance is greater than 100 centimeters, say you have to send a notification, okay, or you can do MATLAB analysis here, whatever. Then you can select your code and you can click on save react. Then what will happen? Here? So when the ultrasonic sensor distance is greater than 100 centimeters, then MATLAB analysis will happen. So what is doing in the MATLAB analysis? We are sending the data, we are executing this program, we are reading the data from the channel and we are posting to the other channel there. So instead of this, you can also select. So instead of MATLAB analysis, you can also select Think HTTP. So when you select Think HTTP, it sends notification to the mobile. So mobile apps will be having REST API. So from the REST API, you will be having some API request, something like, for ThinkSpeak also we have seen some APIs, right? So if you have a mobile server, deployed, then you can have the REST API. Then you can use simple Think HTTP. So then what will happen? When the distance is greater than 100, immediately notification will be sent to the user. So you can send the notification. Okay, I will be explaining the notifications point in IoT Core, AWS IoT Core. Okay, so here it is a bit complicated in ThinkSpeak IoT Cloud because we have to maintain our server, we have to maintain our mobile server, mobile APIs are required in order to send a notification. But on AWS IoT Core, you will have all the servers deployed, and we can usually send notification when the distance is greater than 100. So I'll tell you the same example in using IoT Core. Okay, so as of now, so I'm just explaining you how MATLAB script can be executed. So MATLAB script can be executed in two ways. One, by using time control. So by using time control, you can execute the MATLAB script, and also by putting some condition checks here. By putting some condition checks also, you can execute MATLAB analysis. Okay, so this is what I wanted to show you. So in apps, you'll have two types of apps. One is called time control. So timer control will be there. So the time control is nothing but when alarm is set, immediately, so the action will be done. Okay. So any doubts here? You can also have your own MATLAB code. Okay, it is not necessary that always you have to use the templates. You can have your MATLAB code also. So make sure that your MATLAB and the ThinkSpeak is connected. So as of now we are using free accounts, right? So when you click on this commercial use, so you will have it will be connected with your MATLAB. So no need of opening ThinkSpeak IoT Cloud. You can do it on your MATLAB, because in MATLAB you will have ThinkSpeak IoT toolkit. So you can simply do analysis part there itself. The toolkit itself can read the data, can upload the data directly. No need to open all this. So you can do all those things on MATLAB itself. Okay, as of now I'm using simple free access, which is open source ThinkSpeak IoT account. So I'm just showing you all the types of stuff available here. So that's all. I just wanted to show you how to execute the MATLAB scripts on ThinkSpeak IoT Cloud. So any doubts here? Okay, so let me jump into IoT Core. So let me log out this ThinkSpeak. So let me have a example in IoT Core. Just I wanted to explain the scenario how to use IoT Core. So we have understood how to store data, how to run MATLAB script on IoT ThinkSpeak Cloud. So you can always run some custom scripts also. So that option is also available here. Okay, so I wanted to create an example wherein, so you have an ultrasonic sensor. So whenever ultrasonic sensor distance is greater than 100 centimeters, I wanted to send a notification, okay, to the user. So from this example, I just wanted to show you how to have an IoT notification. So generally IoT notifications are very important when you're building some IoT applications, right? So here in the smart parking example, say if the vehicle is left from the parking zone, okay, if the vehicle is left from the parking zone, I just wanted to send a notification to the security saying that the space is left, so that you can also allow another vehicle to park there. Okay, so here I wanted to create a simple notification wherein when ultrasonic sensor distance is greater than 100 centimeters, I wanted to send a notification to the user, so to the security, wherein, so I'm asking them to have one more vehicle there, so because parking space is available. Okay, so I wanted to do this by using IoT Core. So I wanted to show you this example in AWS IoT Core. So for this you should have an account in AWS. So I am having an account in AWS. So let me log into that account. So what you have to do is, you can create a free account, as I said. So on the day one also I told this. You can also create an account for free, but 2 rupees will be deducted from your card as a verification. So you can also create an account by using this URL aws.msn.com/free, or if you are having AWS Educate account, so you can use an AWS Educate account also. So AWS Free Tier, so AWS Free Tier is available. So if you wanted to have an hands-on experience for free, so on AWS platforms you can use this AWS Free Tier for 1 year only. And here in AWS Free Tier, so there is some constraints here. So if you look at the cloud, it can access only for 750 hours per month, and when you have data, so it is only 5 GB is free. So only for 750 hours per a month, it is free. So you cannot have more than 750 hours per month for free. Okay, so DynamoDB 25 GB of database storage, you can it can be free. Okay, more than 25 GB it is payable. So when you create an account, they will collect your debit card or credit card details. Okay, so when you use more than this in a free tier account, then immediately billing will be generated. So that is why always you have to be very careful while using AWS services. So here I am using a service which is related to Internet of Things. So AWS IoT, yes. So 250k messages, which is 2,50,000 messages, can be published or delivered per month. So you can have 250k messages published or delivered per month. It is free. So in the today's session I will be using only 100-200 messages. So it is okay, but per month it is 2,50,000 only. So generally in IoT, what people do, they will put in infinite loop, right? They forget to stop the infinite loop. Then what will happen? Continuously it will try to send the data to IoT core. That is why you have to be very careful. So while accessing AWS IoT, because every message will be counted, every transaction will be counted. So transaction is nothing but the data which is published to IoT core and the data which is subscribed to the IoT core here. So let me show you how to access this AWS IoT service, because in free tier we are having 250k messages per month, which is free. So I will be using this free tier service from the account, and I will show you how to access the data, and also I'll demonstrate this example, which is when the ultrasonic sensor distance is greater than 100. So I wanted to send a notification through IoT core. So I just wanted to demonstrate this use case so that you can also understand how to use IoT core. So IoT core is very bit complicated when you compare with IoT ThinkSpeak. Okay, so when you compare with ThinkSpeak, IoT core is very complicated part. Okay, so I have explained all this in the first class. So I will explain all this with the help of hands-on. So like in ThinkSpeak it is very simple, right? So when you create an account can be created when you have MathWorks, and you can log in into ThinkSpeak, and then you can create a channel and you can upload the data. But here in AWS IoT you will have a different approach in storing the data. So here what we have to do is we have to create some policies, we have to create some device certificates so that the security, so that they are providing the security to the connections which is connected to IoT core, and also they are providing security to the IoT devices, and also they are providing security to the data which is getting stored in AWS IoT. So that is why in the real-time scenarios in many use cases people use IoT core because of this. So the security is very high when you compare with ThinkSpeak. So all the data will be encrypted and it will be stored in the database. So it is difficult for us to access and also to hack. So that is why AWS IoT is very popular. So we have to understand how to access those kind of data, and also we have to understand how to pass the data to the IoT core. So here what we have to do is we have a terminology called policy. So this policy is very important. So the policy is nothing but what kind of device operations can be done on the IoT core. So say in IoT platform you will have different types of operations. So what kind of operations or what kind of resources the device can access. So we have to create a policy in IoT core. So before doing that, let me log in into my AWS account. So this is so let me log in into my AWS account. Okay, forgot the password. Okay, so it is logging in. So it is a free tier account. It is logging into AWS. In AWS you will have different types of services. Okay, you will have different types of services and you will have different types of platforms also. Okay, so out of which we wanted to use a service, you will have a search bar here. Out of which we wanted to use a service called IoT core. So let me type that. So IoT core, you can able to see the description also. So to connect devices to the cloud. So it is asking us to connect devices to the cloud. So let me click on connect devices to the cloud. So let me click on this IoT core. So when you click on IoT core, it will be redirected to IoT core dashboard. So make sure that the data center region is Ireland. So in Ireland only your the free tier accounts is applicable. So you have to select Ireland. So if you so Ireland will be here, EU-West-1, that is a data center region in the AWS data centers. So we have to select this region Ireland. So then only this the free tier will be applicable. So here it is redirected to AWS IoT dashboard. So this is AWS IoT dashboard. You can able to see different types of options also, which are called onboard, manage, green grass, secure, defend, act and test. So these are the different types of options available on AWS IoT core. So here what is the target? Our target is to send a notification when the ultrasonic sensor distance is greater than 100. That is the main scenario. But if you want to demonstrate that scenario, we have to create a policy first. So we have to make a policy. So policy will be in the secure. So in the secure you will have certificates and policies. So we have to create a policy now. So let us click on policies. So when you click on policies, it will show you what are the existing policies available here. So you can see one policy is available here. So let us create a policy. So on the right side you will have a create button. So you have to click on this create button. So when you click on create button, you can it will give you an option to create a policy. So we have to create a policy. Why we need a policy? Because we have to understand that what kind of actions can be done. So what is published, sending data? What is published, uploading the sensory data? What is subscribe, downloading the sensory data? So is it allowed on the device or not? So that kind of policy we have to create here. So create a policy to define a set of authorized actions. So what are authorized actions? Sending data, uploading data is an authorized action. Receiving data is an authorized action. So we have to create a policy whether your device can upload data or your device can subscribe data. So we have to create a policy for your device. Say if you want to connect Raspberry Pi with the IoT core, if you want to connect Raspberry Pi with the AWS IoT core, so you have to create a policy for Raspberry Pi there. So let us name our policy as Raspberry Pi policy. Our policy as Raspberry Pi policy. So I wanted to connect my Raspberry Pi with AWS IoT core. So I am creating a policy here. Action. What kind of action? So I can transmit data, I can receive data. So let me put star. So IoT colon star. When you put IoT colon star, it can publish data, it can subscribe data. So star indicates that any kind of action is allowed. Okay, but in particular when you write IoT colon publish, then only publishing is allowed. So when you give a permission called subscribe, then only subscribe is allowed. Okay, so here when you put IoT colon star, so any kind of operation is allowed. And the resource ARN, in the resource ARN let it be star. Because it means that in MQTT protocol, IoT core works on MQTT protocol. Okay, so it completely works on MQTT protocol. So here in MQTT protocol you will have a topic name, right? So the topic name can be anything. So that is why we have to put, I have given a star. Okay, star indicates that any topic is allowed. So what is the effect? We need to allow. So let us click on allow. So here we have given an action. So any kind of operation is okay. And the topic name is star, so any kind of topic is fine. So I have clicked on allow. So let me click on create. So when I click on create, immediately a policy is created. So in the policy what we did, so we have given a permission for Raspberry Pi to send data, to receive data, and the topic name in the program can be anything. So it is need not be same always. You can have any kind of topic name. So that kind of policy, that kind of permissions are given. For Raspberry Pi. So Raspberry Pi policy is created. So that's the step 1. So we have to create a policy here. Now policy is created. With the name called Raspberry Pi policy. After creating a policy, we have to create a certificate. So why certificates are required? So we have to understand that whether it is authorized device or not. Say we have created a policy called Raspberry Pi. So when you say Raspberry Pi, you can have any Raspberry Pi, right? Say my Raspberry Pi and your Raspberry Pi. So both are Raspberry Pis, but every Raspberry Pi should have an authenticated ID, right? So my Raspberry Pi should have one ID, your Raspberry Pi should have one ID. So that ID is created by using called a certificate. A certificate is nothing but an authorized ID or authorized digital certificates created for the device to access IoT core. So what we have to do is we have to create a certificate for your device if you want to connect to IoT core. So this is like an identity. So now we have to create an identity by using public key and private key infrastructure. It is like a banker keys. So when you look at the locker system in the bank will be having one key and the customer will be having one key, which is like public key and private key. So the banker key will be common for every customer, but every customer will have a unique key, right? So that is called private key. So here also you will have this public and private key infrastructure created for certificates. So let me show you how to create a certificate for your device on IoT core. Now we have to create a certificate. So let me click on certificates. So there are two certificates which are like private keys. Now we have to create a certificate. So let us create a certificate. So on the right side you will have create. So let me click on create. So when I click on create, it will show us how to create a certificate here. Okay. So one click certificate creation. So you can click on create certificate, immediately certificate will be created. Okay, let me click on that. So my target is to create a certificate which is like creating a digital ID. So when you click on this, so a certificate will be created, a public key and private key will be created for your AWS IoT device. Okay, so let me click on it. So when I click on it, now a certificate is created. Now what we have to do is we have to download all this, okay, onto your desktop PC, and you have to pass them to Raspberry Pi. So let me download all this. So let me put it on desktop. Okay, let me create a folder, IoT STTP AWS. Okay, so let me save all these files into this folder with same name. Click save. So that is called certificate. .cert is a certificate there. and let me download the public key also. Download. So let me save in the same folder, and also let me save the private key also. So we have to download all this in order to access Raspberry Pi with IoT Core. And these are like public and private key. So we have to download public certificate. So this is called private certificate. So this is called private certificate. We have to use public certificate. So this public certificate is common for every device. So that public certificate is called root CA. So what we have to do is we have to click on this download. So when you click on download, it will redirect to another page. So from here we have to download the root certificate. So why we need all these certificates is that, so if you want to connect with IoT Core, everything is authorized. So you will have some encryption and decryption comes in. So that is why people use AWS IoT. So you have to create a certificate, then only the AWS IoT will be accessing your device. So here there is root CA1. So you can click on this. So when you click on this, it will be redirected to one more page. So this is the certificate. So now what we have to do is, this certificate is common for everyone. Okay. So that is why it is showing some encrypted key. So like this, you will have encrypted and decrypted keys in the files which we have downloaded. Okay. So what we have to do is, we have to copy this. We have to copy this. You have to copy this, and you have to go to Notepad. So let me open the Notepad. So you have to paste in the Notepad. You have to paste in the Notepad. After pasting into the Notepad, we have to save this. Okay. So file, save as. So we have to save it in the same folder. Okay. So let me jump to desktop. Let me open that folder, IoT STTP AWS. So let me save here, but save as type should be all files. Okay, because we are saving the certificate. So always keep a point in mind. So save as type should be all files. Sometimes people select text files. So if you select text file, it will be saved as text file. But here we have to save it as a certificate. So CRT. What is that? CRT. One second. Let me show you that. There will be next CRT. There will be an extension here, so we have to save it as same name. So let me write root-ca CRT. So which is certificate. So let me click on save. So here save as type should be all files. It should not be text documents. Okay. So it should be all files. That is very important. So let me click on save. Now the public certificate is also downloaded. Okay. And let me jump back to the folder. So let me jump back to the folder which we have created now, which is IoT STTP AWS. So you can able to see 4 files here. One is private certificate, one is private key, third one is public key, and the next one is root certificate. So we have certificates here. Now what we have to do is, we have to activate the certificates on the AWS IoT Core. Okay, so you have to go back, and here you have to activate them. So when you activate them, then only the certificates will be valid. Okay, so now we have activated them. And we have downloaded them, right? So we have downloaded all these files. So that's all about the process of creating a certificate. Okay, so we have to create a certificate so that that device is authorized. If there is no certificate for the device is unauthorized. So which is like an ID card. For example, say if you want to enter into a college, though you are a student, you should have an ID card, right? So if there is no ID card given, the security will stop you. So here also every device should have a certificate. If the certificate is valid, then what security will do? Security will allow you. So here also, so what we did here, we have created a certificate for our device so that our device can be connected to IoT Core. So in the policy, what we did, in the policy we have discussed about what kind of actions has to be done. For example, say when you look at the college, so you will be having an ID. Okay, so when you have an ID, ID card, then security will allow you. So after then, when you enter into the college, you have to go to the respective class, right? So you can be a CSE student, or you can be an IT student, or you can be an EC student, or you can be a EEE student. So the security will be common, right? The gate will be common, but once you enter into the college, there will be different types of classrooms, right? So based on the department, so you will be going to the respective class, right? So here also the respective class is nothing but policy. So we have given permissions to access published data, subscribe data and all. Okay, though the policy is created if there is no certificate. So though you are a student, if you don't have an ID card, security will stop you, right? So that is how the certificate and policies are very important in IoT core. So after creating a certificate, what we have to do is we have to register your thing. So we have to register your device. So let us do that. Let's jump back to the IoT core and let us register your device. If you want to register your device, then you have to click on onboard, manage. Okay, so in manage we'll have things. So you have to click on things. Things are nothing but devices here. So in IoT core, devices are called as things. So here we have to create a thing. So here we have to create a thing. Okay, in things we have to create a thing. So let us create it. So when you create a thing, so you will get two options here. One is create a single thing or create many things. So we can click on create a single thing. Okay, so let me click on create a single thing. So here let me write some name. Okay, let me write some name, Raspberry Pi. Okay, so space is not allowed, Raspberry Pi, and apply a type to this thing. So that is not required. So groups, I have only one device, so no need to create groups and all. So let me scroll down and click on next. So here we have already created a certificate, right? So no need to create certificate now. So we have created it in the previous step. So let me click on this, create a thing without certificate. Okay, now a thing is created on your AWS IoT dashboard called Raspberry Pi, but as of now no certificate is added. Okay, so let me click on this Raspberry Pi and let me show you something out here. So Raspberry Pi, this is called ID of the device. So this is the ID of the device. You can able to see here some ID will be generated. So unique ID will be generated from device to device. So from thing to thing you will have a different ID. Okay, so in security as of now you don't have any certificates right now for the device. So we need to add a certificate to the device. We'll do it later. So let me show you interact. So this is very important. So when you click on interact, you will be getting some API endpoint. Okay, so this API endpoint is called MQTT broker of your AWS IoT core. So every device will have a unique, every account I should say, every AWS IoT account will have unique API endpoint. So this endpoint will be acting as an MQTT broker. Okay, so let us remember this. Okay, let us copy this. So we cannot remember it, right? So let us copy this and let us paste in the notepad. Okay, so let us create one more notepad file and let us paste this endpoint. Okay, so we cannot remember it, so let us paste that and let us minimize this. So whenever it is required in the program we can do it. Okay, so let us close that certificate. Okay, so let us close this certificate. We have saved it, right? Okay, so we have the endpoint. Here, so which is nothing but broker. Okay, so let us jump into certificates. So let me click on the certificate. I don't know which certificate is created now. So okay, only one certificate is active. So let us see whether it is created now or not. Okay, it is created long back. So let us go back. So I guess the last one is created now. So let us click on it. So September 17th, yes, September 17th is today, right? So this certificate is created. So let us activate it. Let us go to actions. Oh, it is activated. Okay, so let us click on attach policy. So for this certificate I am attaching a policy which we have created in the previous step. So let me click on attach policy. So Raspberry Pi policy is our policy, right? So let me select that. Let me attach it. So a policy is now added to the certificate, and also let me attach a thing. So we need to attach a thing. So we have created a thing called Raspberry Pi, right? So let me select Raspberry Pi and let me click on attach. So thereby the certificate, to the certificate a thing is added. So in policies you can see a policy, in things you can see thing. So in the similar way, when you go back to things, okay, so when you go back to things, so when you see Raspberry, when you click on Raspberry Pi, when you click on certificate security, so when you can see the certificates here, okay, you can see the certificate here. So B4A293 so on. Okay, so now the thing is having certificate, and we have also added policy to the certificate, and thereby the configuration is done. Okay, so let me jump back to the PPT. So now the configuration is done, and we have discussed about MQTT protocol long back, right? So let me skip this slide. So by using MQTT protocol, it will be communicating. Okay, so here the ultrasonic sensor will be acting as a publisher, AWS Endpoint is a broker, and we have Aws IoT Core, which is a subscriber. You know all that. So we have to install this library. So before installing this library, what we have to do is we have to send those certificates onto the Raspberry Pi. So where we have saved those certificates, we have saved those certificates on system, right, on my laptop. So I have downloaded and I have saved it in a new folder. Now let me send these files onto the Raspberry Pi. So let me do that. So for that I will be using one software. Okay, let me magnify. So let me show you what software it is and all. So there is a software called Win. There is a software called WinSCP, which is installed on my system, WinSCP. So you can download it from the Google also, it is open source. So WinSCP. So WinSCP can be used to send files from my desktop PC to Raspberry Pi. So let me open it. Yeah, it is opened. Okay, so it is asking me to enter what is the IP address of Raspberry Pi. So let me enter my IP address of Raspberry Pi 192.168.0.86. Is that the IP address? I guess it is. Username is Pi, password is Raspberry. Let me log in. Okay, now you can able to see on the right side, this is the Raspberry Pi files. So if you remember, yesterday we have created Smart City folder, and morning we have created this program. So yesterday we have created dustbin.py, and now we have created slot gateway.py. Okay, now what we have to do is we have to create a folder. So let me create a folder, new folder. Okay, let me create a folder. So let me write AWS. Okay, click OK. So into this AWS folder, I wanted to transfer all the certificates. Okay, so let me jump to desktop. So in the desktop, I have created a folder called IoT STTP AWS. So these are the certificates, right? So let me drag them. Okay, so it's simple to copy. So we have to drag them to right side. So then immediately you can able to see them in the Raspberry Pi also. So on the Raspberry Pi also you can able to see this. Okay, so like this we have to copy paste, or you can drag drop by using this software, which is WinSCP. So this is a software. So this is open source, you can download it from Google. So let me close this software. Okay, so it's already there on my Raspberry Pi. So on Raspberry Pi, what we have to do is we have to install a library. So let me open Raspberry Pi desktop. So morning we have opened it, right, VNC viewer. So by using VNC viewer, we have to open the Raspberry Pi desktop. So we have to connect with Raspberry Pi desktop. So let me enter the IP address. Okay, so let me enter the IP address here, 192.168.0.86. So it will ask you to enter the password if it is on. Yes, Raspberry is my password. Okay, click OK. Now what we have to do is we have to install some library. So what is a library? So that is there in the presentation. So the library is, what is this? Pip Install Aws Iot Python Sdk. So this library has to be installed. Okay, so this library is not built-in library. So this is a AWS SDK. So we have to install this library on Raspberry Pi. So let us install that. Okay. So sudo pip install AWS IoT Python Sdk. So you have to run this command. Okay. Sudo pip install AWS IoT Python Sdk. So when you run this command, immediately the Python Sdk will be downloaded onto the Raspberry Pi. So I guess it is there with me on my Raspberry Pi. So let's see. Yeah, requirement is already satisfied, means that it is already there. If it is not there, it will be downloaded and it will be installed. Okay. So if it is not available on your Raspberry Pi, it will be downloaded and it will be installed on your Raspberry Pi. Okay, am I going fast? So you are following, right? If you have any queries, you can drop me in the YouTube live chat. Any questions so far? So are you all following? Any questions so far? Okay, no questions, so I am just going ahead. Okay, so the library is installed. So let me come back to the presentation, because I need to use the presentation to tell the syntaxes, because this is a bit complicated. So here, so we have to write a program. So the library is installed. Okay, so we have to write the program here. So let me follow the PPT and also the shell. Okay, so let me go back to the folder cd space IoT smart city, right? So that is the folder which we have created, and we have created a folder called AWS, right? So cd space AWS. So here we are having certificates and primary and the private key and public key. So we have to create programs here. Okay, so we have to write program here. Okay, so sudo space nano space smart parking.py, sudo space nano space smart parking.py. So that is the program file name. So here we have to write program. So before we start the program, so we have to import the library which we have installed. Okay, so let us import that from space AWS IoT Python Sdk dot from this library. So we need some modules. MQTT lib space import space AWS IoT MQTT client. So from AWS IoT Python Sdk, so from this library, so there is a module called MQTT lib. So we have to import this module, and from this module we have to import a function called a method. So a method called AWS IoT MQTT client. So previously we have used paho.mqtt.client, right? So in the similar way, so we have this SDK called AWS IoT Python SDK. From this SDK, so we have module. So here if you look at AWS IoT Python SDK is like library. From this library, MQTT lib is module, and we have AWS IoT MQTT client. So this is method. Okay, from the library and from this module we are importing a method. So that is, it means that. Okay, so and also let me import one more library called time. So for time we need time.sleep function. So let us import time library also. So anyways, time library no need to explain it. So it is simple. So after importing the library, what we have to do is we have to create a client object. We have to create a client object. So let us write the syntax. Client equal to AWS IoT MQTT client of some client name, say madBlocks. You can write any client name here. Okay, so client equal to AWS IoT MQTT client of madBlocks. So after creating the client object, So we have to configure the broker. Okay, so we have to configure the broker. We have to configure the broker. So to configure the broker, what we have to do is client dot configure endpoint. So client dot configure endpoint of, you have to paste the broker, and port number. AWS MQTT will be deployed on a port number called 8883. So instead of 1883, so they will be using 8883. So 8883 is a port number. In between the single quotation, we have copied it on the notepad, right? So the endpoint, which is broker. So this broker we have to paste it there. So Control A, Control C. So let me paste it there in between the single quotation. Okay. So we have pasted in between single quotation and then comma 8883. Okay, I will share this program anyways. 8883. So we have configured the broker. After configuring the broker, we have to pass the certificate. Now we have to configure the certificates. Okay, so let us do the configuration here. So which is nothing but client dot configure credentials, that is called credentials. Okay, so client dot configure credentials. So if you, the second C is capital. Okay, so here the next word, the second word starting letter should be capital. Okay, so here endpoint C should be capital, the second word is credentials, C should be capital. So here we have to pass, what we have to pass is, we have to pass the public certificate. What is a public certificate? Public certificate is nothing but root-ca.crt. So this is the name which is given, right? So let me also check that. So what is the name? Yep. So let us use this as reference. Okay. Okay. So let us use them as reference. root-ca.crt. So we have to pass the public certificate. After passing public certificate, you have to pass the private key. So what is the private key name? Single quotation open B4A 293997 A hyphen private dot pem dot key. So we have to pass the private key. After passing private key, we have to pass private certificate. So what is a private certificate there? So private certificate is nothing but the first one, B4A 29399. So everyone will have their unique file. Okay, so B4A 2939997A hyphen certificate dot pem dot crt. So this is a certificate extension there. So we have to pass these three files. Okay, so we have to pass the root certificate. After passing root certificate, you have to pass, so let me write it here, okay, for you to understand. So we have to pass root certificate, and also we have to pass the private key, and also you have to pass the private certificate. Okay, we have to pass these three files. So root certificate, private key, and also private certificate. So as an argument. So generally they will be having some file names, right? So I have given those file names there. So after that, what we have to do is, we have to talk about what is the published queuing here. So generally there will be finite published queuing, and you will have infinite published queuing as well. Okay, if you want to publish for only one time, that is called finite published queuing. If you want to stamp continuously, if you want to send continuously, then that is called infinite published queuing. So here we have to call the syntax. Okay, the client dot configure offline publish queuing. Okay, so if you want to send multiple times, that is nothing but -1. If you want to send one time, that is 0. So finite publish queuing is 0, infinite publish queuing is -1. So we have to configure this. After that, you have to configure the data transfer rate. So you have to configure the data transfer rate. So let me do that. Client dot configure draining frequency, that is called draining frequency on AWS. Say the frequency as 2 hertz. Okay, so when it is 2 hertz, you can easily calculate the time rate, right? So 1 by frequency, so you will be getting the stamping time rate. So where we can use this. Okay, this is a default frequency. You can put 2 or you can put 4. So it's all based on the time rate, so the data transfer rate. And then you need to configure some timeouts here. So say if your internet is weak, so there will be timeouts here. We have to configure the connect disconnect timeout. So let us do that. Client dot configure of connect disconnect timeout. So say if your server is disconnected, you need to connect it again, right? So let's say a 10 seconds of time to connect again if the server is disconnected. So this is called timeout. And also there is one more timeout called MQTT operation timeout. So we need to configure that also. So we have to configure MQTT operational timeout. Say if MQTT server is disconnected, so we have to make that timeout also. We have to mention the timeout also here. Client dot configure MQTT operation timeout. Say you can have 10 seconds or you can have 5 seconds, whatever. Okay, so we have to configure all this. So once they are configured, so your MQTT broker will be configured. So generally when you use broker.hivemq.com is a very short program. Okay, but here what we have to do is we have to connect with server. Here also you'll have the same procedure, but you will have certificates so that the connection will be authorized. And we have to create a client object, we have to connect with broker, we have to configure the certificates, and then we have to talk about all this. So what kind of operation timeouts are there, what kind of how much time you will take to disconnect and connect here. And also you have to talk about what is the data rate, and also you have to talk about whether it is finite publishing or infinite publishing. So all these are little configurations on AWS IoT Core. And next what we have to do is we have to define a notification function as PAHO MQTT package. So we have to define a notification function as we did yesterday. So notification of, so we have to pass the same details, client comma user data comma message. Okay, these are the three objects. Okay, so let us print message dot payload. So we are aware of this, right? So yesterday also we have used the same syntax. Okay, def notification client comma user data comma message print of message dot payload. Okay, so let us connect. So now let us connect. So everything is configured. Let us connect. So let us connect with AWS IoT Core. If your certificates are correct, if there is no spelling mistake, then it will be connected with broker. So let us connect client dot connect. Immediately it will be connected with broker. Okay, so let's say print connected to AWS IoT Core. So I am using a print statement here, and then let us have a delay of 2 seconds. Okay, time dot sleep of 2. Let us subscribe client dot subscribe of, let's say IoT / parking, whatever, IoT / parking. So let's say which function has to be invoked. Okay, so one, which is nothing but quality of service, which means acknowledgement. Notification is a function here, so we have to pass the function object. So client dot subscribe of topic name. So to this topic we are subscribing out there. And the quality of service is one, which means acknowledgement. So notification, the quality of service will be there in the WhatsApp also. So in the earlier versions of WhatsApp there is no single tick, double tick and all, right? But in the newest versions of WhatsApp from the last 2-3 years, if you see, you are having single tick, double tick and also blue tick. That is nothing but quality of service, whether the message is received or not, whether the message is sent or not, so whether the message is seen or not. So they are nothing but quality of services here. So here also we are putting quality of service as one, which is acknowledgement. Okay, so let us have an infinite loop while true colon. So here we have to read the data from sensor, right? So let us call, okay, let us have a sample value first and then we'll write the sensor value. Okay, So distance equal to say 170.34. Okay, but we have to read the data from sensor. We'll read it. Okay, I'll show you the syntax how to read it. So, and then we have to create a payload. Okay, and we have to create a payload. So this payload is very important. So what we have to do is we have to prepare a JSON, but through dictionary, through strings. Okay, so what we have to do is we have to create a dictionary, single quotation, double quotation, say distance, double quotation, colon, plus str of distance, plus we have to end that flower bracket. Okay, so flower bracket close, single quotation. Okay, so we have to prepare a JSON format here, which is nothing but single quotation, flower bracket close. So here what will happen? So let us print the value of payload also. We will understand. Print of payload. So we wanted to send this payload. Okay, so here we are sending a distance called static value. Okay, we are sending a static value here, but instead of static value we wanted to read the data from sensor and print of payload, and then let us publish the data. Client dot publish of say IoT slash parking. So let's say this is the topic, comma payload, and let's say quality of service is 0, so no need of acknowledgement, or you can put acknowledgement, whatever, and then let's have a time dot sleep of 2. So this is a program for publishing the data. Okay, we have not read data from sensor. We have given a sample value like 170.34. Later, after seeing the output, we can write a program for the reading the data from sensor, because yesterday we wrote it, right? So let us use a simple copy paste here. So let me exit from this. Let me run the program. Control X Y enter. So let me run the program. Sudo python smart parking.py. It is connected to AWS IoT Core. Yes, distance is getting published. Okay. So let me jump into the AWS IoT Core. Okay. So let me jump into AWS IoT Core. Let's see whether the data is receiving or not. So here what we have to do is we have to go to test. Okay. So you will have test here. So we have to click on test in order to see whether the data is being receiving or not. So let me click on test. So then it will ask me to subscribe for a topic. So let us write the same topic, IoT slash parking. Okay, so IoT slash parking. So let me, where is this? Click on subscribe to topic. So when it is subscribed to the topic, you should see the same values which are publishing from Raspberry Pi. You can able to see it here. IoT slash parking, distance 170.34. So these are the messages coming from Raspberry Pi to IoT Core. So these are the messages coming from Raspberry Pi to IoT Core. So we have given a constant value of 170.34, right? So thereby it is showing 170.34 on the IoT Core platform. Okay, on the IoT Core platform, what we did here, we have subscribed on a topic called IoT slash parking. You can able to see here. So distance is getting printed continuously. Okay, it is printing continuously because it is an infinite loop, which is nothing but infinite publish queuing is enabled, right? So it is continuously transmitting the data. Okay, so there was a question, shall we name protocol as a broker? So protocol is MQTT, broker is the endpoint. Protocol is MQTT, the broker is the endpoint. REST endpoint is acting as an MQTT broker here. So you will have the unique endpoint from account to account. So if you open your AWS account, you will have one endpoint. If I open my AWS account, I will have this endpoint, which means that this is a private broker. This is not a public broker. So by using this broker, you cannot communicate. By using this broker, I can communicate. So I can ask my Raspberry Pi to send data to IoT Core, and you will be having your own private broker. So yesterday, if you see, we have used broker.hivemq.com. That is a public broker. But here, this is a private broker. So it will work only for my account. Okay. So because we have this certificates and all, right. So by using that, it will identify to whom account it has to be connected. So it will be doing accordingly. So we have this endpoint here. So let me minimize. So the distance is getting printed, right? So let me read the data from sensor and let me post it here. Okay. So let me magnify out. So in MQTT, in Paho MQTT, in the see the message MSG or MESSAGE, so those are given in the library objects. Okay, so they are predefined objects. In Paho MQTT package, they will be using message as MSG. In AWS IoT Python Sdk, they will be using message as MESSAGE. So that is the difference there. So it is based on the library. So when we are using Paho MQTT, so we have to take their predefined object names. So that is why in the yesterday's program we have taken MSG. But today now we are using AWS IoT Python Sdk. So we have to take message object MESSAGE only. So let me stop the program. It is running continuously. So let me stop the program and let me add the syntax. Okay. So let me add sudo nano smart parking.py. So here what I'll do is, so previously yesterday we have written a program for ultrasonic sensor, right? So the time is running up. So let me do little copy paste of the program. So as we have written yesterday, so what is this? Yep. So let me copy this program from here. Threshold to 10. So there is no need of threshold. So let me do it from trigger. Okay. So trigger to here. Okay. So let me copy this. Let me jump back to the program. So here what I'll do is we have to define the function. So let me define it here. Okay, so let me define it here, paste. So I have pasted here. So let me, instead of while true, there are two while trues here. This is one while true, and here also we have one while true. So we have to remove one while true. Okay, so there should not be two infinite loops in one program. So they will go to deadlock. So what we have to do is we have to so let me rename. Okay, so let me rename this while true with def distance ultrasonic. Okay, whatever. Let us write measure. Okay, measure distance, whatever. So let me write it down. So measure underscore distance. The function names are important, right, to call them. So let me return a value. So what value I have to return? I have to return distance, right? So let me return a distance here. Return distance. Okay, so that I can access that variable. I can call it here. So let me call it from here. Distance equal to measure underscore distance. Okay, so we are calling the function here. Thereby the entire block will be executed, and it will be returning the distance value into the distance variable here. So now the sensor value is red, right? Sensor value is red, isn't it? Now the sensor value is red. Now to run this program we have to import some libraries. Okay, we have to import a library called import rpi.gpio as gpio, and also we have to disable the warnings, set warnings to false. Okay, so the library is included and we have set warnings false, and we have this ultrasonic sensor connected with Raspberry Pi. So yesterday I have explained all this, and we have the function called measure underscore distance. So that is also there. So it will return distance. So let me run the program. Let me run the program now. Now we have the dynamic value of the sensor. Okay, so now let me run the program. So if I run the program, so the dynamically it has to read the distance, connect to AWS IoT Core, and you can able to see distance as 175.63. So let me put my hand opposite to the sensor. So now the distance is less, right? 19.47. So that 19.47 is getting transmitted onto the IoT Core. Let me see the same values in the IoT Core also. So let me jump back to AWS IoT platform, and let me see whether I am receiving the same data or not. Okay, so let me clear. Okay, so you can see it, right? 173. So let me put my hand. 24, you can see 24 here, right? So can we receive that 24 here? So let's see that. Yep, you can able to receive here. So you can see 24, 7.38 distance is coming from Raspberry Pi. So you can see the variable value, right? Now it is reading this data from sensor, and that data it is sending data to ThinkSpeak AWS IoT Core. Okay. So let me stop the program for a while. Okay. So here, when you are sending data through MQTT protocol, so in AWS IoT Core, what happens is it will be taking a message in message object. The value of the data that you want to transfer should be appended to a key called payload. So generally, if you see, I'll show you it once again. Okay. So here, payload is nothing but what? Payload is nothing but the value. So the value which is getting transferred here. In generally in AWS MQTT message, when you are sending a message is an object. Okay, message is an object. So in this object, you will have set of key value pairs. You will have set of key and value pairs. So what kind of key value pairs? For example, say you will have a key called payload. You will have a key called payload, and you will have data. So what data you wanted to write? So what is the data you wanted to write here? Flower bracket open, distance colon, distance flower bracket close. That is the data. Okay. You will have a key value pair called, say, topic. So what is the topic here? IoT/parking. So here you will have IoT parking and ID colon user ID. So you will have lot many number of parameters assigned to message. Okay. So message is nothing but an object which is combined of different key value pairs, out of which payload is one. Payload is one key value pair in message object. Okay. And in message object, you will have a payload, and to that payload you will have data. So what is this data? This is the sensory value. So this is the sensory feed. So sensory feed cannot be sent directly. So in the payload, that is a generalized reference. Okay. In PAHO MQTT library or in AWS MQTT library, the data will be protected with the help of key value pair. So in Python, if you see dictionary, so dictionary, why dictionary is very popular in Python? Because the values cannot access through index. You cannot access through index. So if you want to access data, what you have to call? You have to call its payload. Payload is nothing but carrier. Payload is nothing but carrier here. So generally in rocket science we use a keyword called payload. What is payload? Payload is nothing but which holds your message. Okay, so here payload, which is what it is holding? It is holding your data, which is nothing but sensory feed. So payload is nothing but an object which is defined in message object. So a payload is nothing but a key to access your value. What is that value? That value is nothing but your data. Okay, if you call payload, you will get your value. Okay, which is nothing but key. So for example, say I will show you something out here. So let me jump to notification function. Okay, let me jump to notification function. In the notification function, if you see, so what you are accessing here? Message.payload. You are not accessing message directly, because message will have message.payload and message will have different types of keys, message.topic. So you will be accessing a topic name here. But when you write message.payload, you will be accessing your sensory feed. Okay, you will be accessing sensory feed. Now let me run the program. I will show you the difference. Control X, Y, enter. Sudo python smartparking.py. Say now you can able to see. So you will get topic name, and also, so the topic name is printed here. The topic name and also the message. So what is the message there? 173.09 distance colon 173.47, that is the message that you wanted to, that you are sending out here. Okay, so the topic name is IoT/parking. So payload is nothing but a key to access your sensory feed. Okay, payload is nothing but a key to access your sensory value or sensory feed, whatever. Okay, so let me jump to notification. So what we are doing here, still now we have sent data to the AWS IoT Core. Now here we have to create a rule. We have to do little analysis. So we have to create a rule. So what kind of rule? If the distance is greater than 100 or say less than 100, okay, whatever. If the distance is greater than 100, we have to send a notification. So that is what our target is, right? So we have received our data. Now we have to create a rule. So before creating a rule, let us have a new service that I wanted to discuss here. So let me show you a new service which is called notification service. So you will have notification service available on AWS IoT Core. So that notification service is called simple notification service. Okay, you will have simple notification service. So let me select simple notification service. So this is called SNS, simple notification service. By using this simple notification service, you can send a notification. Okay, so let us create. So this simple notification service is also executed on MQTT protocol. Everything they use MQTT protocol because it is lightweight and it is fast when you compare with HTTP. Okay, this also communicates on MQTT protocol. If you are good at MQTT protocol, you can understand all this. Okay, so what we have to do is we have to create a topic. We have to create a topic here. Let me click on topics. So there is a topic called temperature. Now let us create a topic. So you'll have create topic here. We have to create a topic. So at topic, at name, let us write parking. Parking is a topic. So display name, that is okay. You can keep it optional. Let us create a topic. Now the topic is created. Now what we have to do is we have to create a subscriber also. Okay. So whenever this topic is called, so the subscribers will get a notification. The subscriber can be mobile application. The subscriber can be a mobile SMS notification, or the subscriber can be an email notification. It can be anything here. Okay. So we have to create a subscriber. So to create a subscriber, you will have create subscription here. So let me create a subscriber. So let me select protocol. So in the protocol, you will have HTTP, which is another mobile API, HTTPS, so HTTP secure, HTTP, which is non-secure, email JSON, Amazon Simple Queue Service, AWS Lambda, and SMS. If you want to send SMS, you can send SMS. Okay, but SMS how I wanted to. I'll take email. Okay, I can open my email on my browser. I can show you the output. Okay. So let me put email, or you can select SMS also. So if you select SMS, you have to write the mobile number. Okay, if you select email, you have to write email ID. Okay, so I'll write my email ID here. madhu@gmail.com. So I'll write my email ID here. So let me add create subscription. Okay, so then what will happen? So the subscription, I have created a subscription here. Let me go to topics. So let me click on topics. Let me click on parking. So when I click on parking, so you can able to see the pending confirmation. So I guess I have got an email from the AWS. So let me activate that. Okay. So let me activate the mail. Okay. So gmail.com. So I have created a subscriber. So immediately the subscriber will get a notification on their mail saying that someone has added to the topic. Okay, so let me activate that AWS notification. So let me click on it. So you have chosen to subscribe to the topic parking. So please confirm the subscription. So verifying the subscription here. Let's click on confirm subscription. So when I click on confirm subscription confirmed. Then let us reload this page. Okay, let us reload this page. When you reload this page, you can see instead of pending confirmation, you should see success. Okay, so it means that your subscriber has accepted your request. Okay, yes, it is success. So the status is confirmed, email, and we can send notification to this email ID. Okay, so the subscriber has accepted it. So let me jump back. So what is the topic name? Parking. So when you send something to this parking topic, when you send some message to the topic, then immediately it will send all the data to the subscribers. You can have n number of subscribers here. You can have 100, 200 subscribers here. Nothing will happen. So when something comes to this topic, then immediately to all the subscribers it will send. Okay, it is like Twitter. When you post a tweet, what will happen? To all the subscribers it will send, right? So here also you can have multiple number of subscribers. So when you send something to this topic, then immediately that message will be sent to all the subscribers. So as of now we are having only one subscriber here. Okay, so let me jump back to IoT Core. So we have created a topic and then we have created a subscriber, so that whenever something comes to the topic, the subscriber will get that topic message. So let me jump back to IoT Core. So in IoT Core, you will have, where is this, act. So in act you will have rules. So we need to click on rules. Now here we have to create a rule. Okay, so what is the rule here? If distance is greater than 100 or less than 100, whatever, so we have to send a notification to the topic. Then what topic will do? So topic will send data to all its subscribers. Okay, so let us create a rule. So let us create a rule like parking. So description you can leave it. So here, so what is the topic that you want to send? What is the topic name? I forgot the topic name. What is the topic name? So we have to pass the topic name. One second, I forgot the topic. IoT/parking. So we have to write the same topic name here. Okay. So we have to pass. Is it visible properly? Okay. IoT/parking, where distance is greater than. Let's write less than. Okay, let's write less than. Whatever, you can write any condition here. Okay. Select star from IoT/parking where distance is less than or greater than whatever 100. Okay. So this is a rule. So here we have to write a query. So what is a query here? Select star. So select all the data coming to this topic IoT/parking. Where distance, so that payload is having some distance column, right, value. So where the distance is less than 100. Okay, when the distance is less than 100, what we have to do? We have to create. So we have to create some action. So let us click on add action. So here we have to send a message as an SNS push notification. Okay, so let's select this. Send a message as an SNS push notification. Let's select that. Let's click on configure action. So no topic selected, but we have created a topic called parking, right? So we have to select parking topic, and message format you can keep raw, whatever. So we have to create a role. So let's create a role. So let's write parking. So this role is nothing but this is called the permission role. Okay, so we have to take permission so that it can access the topic in SNS. So let's create a role. So policy is attached, we can able to send notifications. Let's click on add action. So now you can able to see here when the distance is greater than less than 100, so it is action is like send a message as an SNS push notification on the topic called parking. So on the parking topic on SNS service we have created a subscriber, right? So then immediately, so whenever the sensor value is less than 100, immediately it sends a notification. Okay, let us execute this. So let us save this. Okay, let us click on create rule. So when you click on create rule, so we have to enable it. So let us enable it. Okay, now we have enabled it. You can enable by clicking on this horizontal ellipses. Okay, so you can click on enable, so it will be enabled. That's fine. Okay, so everything is done. The rule was enabled and the notification we have created. So let us reload, let us go back to the page email and let us run the program. So when you run this program, if you see a distance value is less than 100, okay, it has to connect with IoT Core. And then if the distance value is less than 100, so here it is 174, right? So notification will not be received, right? So let us put my hand opposite to the sensor with less than 100 centimeters, then obviously it has to send a notification. It is 10.2 centimeters, right? So I have to get my notification. Let's see whether I have received the notification or not. Okay, let me jump to email. Yep, I have received it. Now my distance is less than 100, right? What is the rule which I have created? I have created a rule in such a way that the distance is less than 100. So what I am getting here, your distance is 10.2, which means that the same message which is received is emailed to my email ID. Okay, instead of this you can also write something like the parking slot is available, so you can ask, or you can send a mobile notification also, or you can send a app push notification also. So you can integrate all those things directly with AWS IoT Core. So but if you want to create mobile apps, again that is a different scenario, right? So you have to work on mobile servers, you have to select the framework, and then you have to create an APIs, and that API has to be integrated to here. And when you integrate that API here, then it can be communicated directly, so your messages will be delivered. So that's how you need to do, right? So that's all about. We have received a notification when the sensor distance is less than 100. Okay, so any doubts, any queries? So we are done with this. So like this you have to create a certificate, you have to create a policy, you have to add a device, and then you have to write a script. I will share the script anyways to your Google Colab, so that you can also take it as a reference for creating different IoT projects related with AWS IoT. So any doubts here? So that's all. So any doubts? If you have any doubts, you can ask me. Any doubts? If you have any doubts, you can ask me. That's all about this session, which I wanted to show you the demonstration of Raspberry Pi device with AWS IoT Core. So thank you all. Thanks for joining me today. So we have successfully completed 4th day also. This videos will be live on YouTube, so you can play whenever it is required. So we'll also share this YouTube links to your email IDs after this course. So I'll meet you back tomorrow at 11 o'clock with a new topic. If you have any queries, you can drop me a message on the mobile number which is scrolling down to this YouTube live, or else you can also mail me on the email ID. So I'll reply accordingly. So I would like to thank all the participants for joining me today. So we'll meet you tomorrow at 11 o'clock. Thank you all.